Okay, this is on properties of logarithms or laws of logarithms. One thing, the laws of logarithms parallel the laws of exponents. So separate your paper into two columns for this first part.
All the way down?
Just right about to there. And on this side, we're going to do laws of exponents. And on this side, we're going to do laws of logarithms. Okay, and the laws of exponents you already know. So they parallel each other. If you said x to the m power times x to the n power, when you multiply monomials and the bases are the same, add them. So it would be x to the m plus n power. The laws of logarithms parallel that. The first law of logarithms says if you have the log of m times n, and I'm going to use a base b. They use b for the base. If you're multiplying the numbers, since they parallel the laws of exponents, you add their logarithms. So it's the log of m base b plus the log of n base b. And part of that is in the history of math going back, they didn't have calculators, so if you had your choice, would you rather add or would you rather multiply? Well, their choice was to add. So, okay, second law of exponents. If you had x to the m power divided by x to the n power, when you divide monomials and the bases are the same, subtract the exponents, x to the m minus n. Okay, and that law parallels the second law of logarithms. The log of m divided by n base b. If you're dividing the numbers, then you subtract the logarithms. So it'd be the log of m base b minus the log of n base b. So if you're dividing the numbers, subtract the logarithms. The third law of exponents, okay, is raise a power to a power. If you have x to the m power and raise it to the n power, when you raise a power to a power, you multiply. Yep, multiply the exponents. And the third law of logarithms, if you have the log, and they use n to the p power base b. Third law of logarithms says this exponent will go out front and multiply. So you'd have p times the log of n base b. So for example, if I had the log of 7 squared base b, that's 2 times the log of 7 base b. Okay, that exponent goes out front. Those are the three laws of logarithms, and if you always remember, they parallel the laws of exponents. So I want to go through some examples using those three laws, and it will just say solve. First example: if you have 3 log of x base 5, that's a base, so write it as a subscript, minus the log of 4 base 5 equals the log of 16 base 5. Okay, it's 3 log of x base 5 minus the log of 4 base 5 equals the log of 16 base 5. Okay, first I'm going to do this one step at a time. Third law of exponents, this goes back. So that'd be the log of x cubed base 5 minus the log of 4 base 5 equals the log of 16 base 5. Okay, then I'm subtracting the logarithms. So what was I doing with the numbers? Yeah, if you're subtracting the logarithms, then you're dividing the numbers. Okay, so we're subtracting the logarithms, so it'd be the log of x cubed divided by 4 base 5 equals the log of 16 base 5. Okay, the bases are the same on both sides, therefore this x cubed over 4 has to equal 16, so set them equal. And that's like 16 over 1, you can cross multiply. So you'd have x cubed equals 16 times 4 is 64. Take the cube root of both sides to get x equals 4. And remember, you should check them back in the original, okay, but 4 does work. Okay. Any questions on that one? Okay, second example.
Malachi, please return to Ms. Robinson through Malachi.
Okay, so you have the 4 times the log of x base 2 minus the log of 5 base 2 equals the log of 125 base 2. Okay, applying the third law of logarithms, this goes back up here as an exponent. So that'd be the log of x to the 4th base 2 minus the log of 5 base 2 equals the log of 125 base 2. Same idea, you're subtracting the logarithms, therefore you were dividing the numbers. So this will go back to the log of x to the 4th divided by 5 base 2 equals the log of 125 base 2. Those bases are the same, so therefore you can set x to the 4th over 5 divided by 5 equal to 125. That's like over 1. Cross multiply, and you get x to the 4th, 625. Take the 4th, and this, remember on your calculator, you can take the 4th root, type in the 4 first, and put in 4, and then the math key. And on the newer ones, it actually, it's number 5, the x root. On the newer ones, it actually puts a little box where you can type it in, 625. You should get 5. Because basically you're saying what number times itself 4 times would give you 625, would be 5. Remember, you can also go back and do it this way. The 4th root of 625 is also 625. This index is the denominator, and to the first power, that's the numerator. So on your calculator, try 625 and raise it to the 1/4 power, and you should get the same answer. Remember, a square root is to the 1/2 power, a cube root is to the 1/3 power, and so on. Okay, another example. Say you have the log of x base 8 plus the log of x minus 12 base 8 equals 2. If you're adding the logarithms, what were you doing with the numbers? Multiplying. So that would be the log of x times x minus 12 base 8 equals 2. If you're adding the logarithms, you were multiplying the numbers. Okay, now you're in logarithmic form. To solve it, go to exponential. Your base is 8. Remember, a logarithm is just the exponent. So it's 8 squared equals x times x minus 12. So all I'm doing there is going from logarithmic form to exponential form. So you'd have 64 equals x squared minus 12x. get it in standard form equal to 0, so subtract 64. You'd have 0 equals x squared minus 12x minus 64. From there, it's a quadratic. You can do factoring, you can do complete the square, you can do quadratic formula. This one is factorable. Two numbers that multiply together give you 64 and differ by 12. 16 and 4, and 16 goes with the minus sign. Set those equal to 0. So x would equal negative 4. X minus 16 equals 0, so x would equal 16. And on this one, if you go back and check, if you got to check it back in the original. If you put negative 4 back up in here, you'd be taking the logarithm of a negative number, and that's not possible. Same thing if you put it back here, you're going to get the logarithm of a negative number. So this one, you reject. Okay, so your only answer would be 16. You'd have to check 16 too, and it works. Okay, when you check your answers back in the original. Okay, back in, all the way back into the original problem. Yep. Okay. The last one, I think, just as a review. If they ask you for the log of 50 base 5, on the newer calculators you can use the math key and the log base, but you should also know to use the log change of base formula. It's the log of the number, the log of 50, divided by the log of the base. Okay, do that on your calculator. What decimal do you get? Go 4 decimal places. 4307. Okay. So you can either use a log base if you have the new thing on your calculator, but sometimes you may not have that new calculator. So it's the log of the number divided by the log of the base. Okay. Okay. Any questions on that? Okay. I'm going to give you time to work.